colors today on the board. All right. So I'll give you the formula straight away. So if your f of x is sine theta, your f of theta, I should say, then your f dash theta is cos theta. We can prove this using first principle. I'm not getting into it, right? More so, if I've got f of theta equals to sine k theta, so your f dash theta is k times cos k theta. Again, the chain rule comes into the picture. Let this be u. And this is what? Du by dx times dy by du. Whatever is inside, you find the differential of that expression, place it here, flip sine to cos and stuff inside, and that's your f dash theta. Right? Everything remains the same. The stuff that we've done for right from the chain rule, right to e raised power x, then log x, and then here. The only thing that you need to remember is sine converts to cos. Right? Does that make sense, Romel?
Yeah.
Okay, and you see, I mean, we can talk about it later. I mean, I don't think it's you can go to the books. All your complementary angles comes into the picture. That's why sine changes to cos and stuff, right? And now, if my f, this color is visible on the board, right?
Yeah.
You okay? If I have f of theta equals to cos theta, then what does that become? Minus sine theta. F dash theta is minus sine theta. And if I have an extension to this, okay, f of theta is cos k theta. So, what would that be? F dash theta is k times minus sine and stuff inside, k theta. So which is minus k sine k theta. Remember, does that make sense?
Yeah.
Yeah?
Yeah.
Alright. One more thing to remember. You've got three circular functions that you normally play around with, not six. Sine, cos, and tan. So if your f of theta is tan theta, then your f dash theta, or probably I say k theta, tan k theta. So your f dash theta equals to k square, sorry, k times secant square k theta. Now the secant theta is 1 over cos theta, basically. That's a new circular function that is used when it is a derivative. All good? Any drama so far? Anyone? No? All good? All right. Now, let's try to find the differential of two circular functions. And we'll try to compare and see how we are going to solve them. So if I say y equals to sine 2 theta, can you find the differential of this? Ramel, done?
2 cos 2 theta.
2 cos 2 theta. Simple. Differential of this value, and you just flip it. Right? Let's think about this one. Y equals to sine square theta. What will happen here? What will happen here? Any thoughts around it? Sine 2 theta and sine square theta.
Do we just like put it at the front?
No. No. Apologies, you can't. Alright. Chris, any thoughts here? No. So you can't say 2 sine 2 cos theta. No. This square is not that easy to, as in it's not that straightforward. What you will do is, again, chain rule. You'll say let u equals to sine theta. What does this function become, Romeo? It becomes y equals to u squared. Yes. Can you now, Aishka, say dy by d theta? What is sine theta? Cos theta, right? Yes. And Chris, what is y equals to u square? What is dy by du? 2u. Now, just multiply the two. So I'll say my dy by dx is 2 times u was sine theta. Sine theta times cos theta. That's the answer. Did you get it? The difference. Did you get it? You got the difference. Never do it to the front. No. The power of a circular function is far more different than a power of a polynomial. Okay? Did you get it? Yes? Remember that. And then you can have a mix and match of this. Can I take it off the board?
Yeah.
Quickly? Aishka, does that make sense?
Yeah.
100%?
Yeah.
Alright, now let's combine the two then and see what happens. So I say sine square 2 theta plus 1. Let's say this is y. Can you now use both the techniques to solve this? What will be u here? What will be u here? Because that's the trick to enter into this question.
Sine 2 theta plus 1.
Wonderful. Sine 2 theta plus 1 will be u. Now go for it. Aishka, did you get it? What u would be here?
Yeah.
Yeah? Okay, if this is u, then what is du by d theta? I know the differential of this function, which is 2 times sine becomes cos. Cos 2 theta plus 1. Is the first step clear? If I come from here to here. Yes?
Yeah.
If this was u, what is y? Y is u square. Correct?
Mm-hmm.
So what is dy by du? 2u. Yes, Romeo?
Yeah.
Yes, Ayushka?
Yeah.
And what is 2u? 2 times sine 2 theta plus 1. Now chain rule just tells me to multiply these two. So you multiply these two values. 2 times 2 becomes 4. Then sine 2 theta plus 1 cos 2 theta plus 1. Where did you go wrong, remember?
The U.
And where, till what point have you done it, Ayushka?
So, you know when it says y is equal to u squared?
Yeah.
I didn't know it was going to be u squared.
Why? If
Because
this is u, then that's the first thing that you should be doing always, always. When you assume something to be u, change your y to the u's.
Because I thought like squared means it would have to square the entire thing, like including, yeah,
Let it be. So what?
it doesn't make a difference.
Circular function. Y equals to sine x, let's say. What is y square? I'll say sine x whole square. And when I open this up, what will that be? Sine square x, no? Yes or no? I won't say sine square x square. No, no, no. Don't do that. If your y equals to tan theta, so your dy by dx is k times secant square, where it is k theta square, k theta, right? Remember that rule. So if you remember that rule, then can we quickly do tan y equals to tan 3 theta, I think there's a slight change, not the 3 theta, it is 3 theta square plus 1. So can we do this question? And that's the rule on top. And I need to find dy by dx. Use the chain rule, please. Ayushka, what will be u here?
Tan 3 theta plus 1.
No. You would assume your u to be a full circular function if you got a square, if you got a power here. For example, here. Then you assumed your u to be this function. But then if you've got something like this, where you haven't got any power here, then this is the u, the inside bit. Romel, does that make sense?
Yeah.
Romel, what's the answer?
I got 2 and then secant squared 12 theta.
2.
Yeah.
You said 2. Aishka, what's your answer?
I'm almost done.
Alright. Chris, what's your answer?
I got 18 theta.
Incorrect. Let this be u, correct? U equals to 3 theta square plus 1. What would y be? Y equals to tan u, correct? Yes.
Yeah. Oh,
Du by, let's solve this. What's dy by du? If it is k is 1 basically, so 1 secant square u. Yes, Romel?
yeah.
So I've done my first bit here. Let's pick this one up. Du by d theta is 6 theta. And then I'm just multiplying the two, no? What's that big deal in it? Anushka, did you get this? Did you get what I've just done on the board? Yes or no? Louder, please. Yes or no?
Yeah.
Okay. Secant square u was 3 theta square plus 1. That's my answer. Where did you go wrong? You said 6 theta, no? So how come 18? Where does 18 came into the picture?
The value of k,
Which k?
when I derive tan,
See, y equals to tan u, no? Because all of that is u. This becomes tan u. And tan u is what? K. This is 1 times u basically.
yeah,
K is 1. So 1 times secant square u, which is secant square u. Yes? Does that make sense? Aishka, where did you go wrong? Tell me, that's fine. In this working out, what did you not understand? That is fine if you didn't understand from the top. Say and save time. That's okay. Tell me.
I don't understand like this.
What?
Why we just times it by u.
Here?
Yeah.
Aishka, my chain rule says dy by du times du by dx. So two differentials. The first differential is this, and the second differential is this. So I just multiplied 6 theta times secant square u, and u was 3 theta square. So I just plugged it in. No? Yes? 100%. Ask. Quick. Ask. Anything else?
could we do another question?
Shall we? Or shall we move ahead? Another one?
Yeah.
Okay. You want to do a tan or you want to do any chain rule, right? Let's do a chain rule. Yeah?
Maybe 10.
10? Okay, let's do a 10. Tan within brackets, writing it right on top. Tan 3x plus 1 y equals 2. Quick.
Yeah.
Yeah. So you assumed u equals to 3x plus 1, and then your y becomes tan u. So your dy by du is secant square u, which is secant square 3x plus 1, and here your du by dx is 3. You times both of them, so the answer is 3 times secant square 3x plus 1. Finish. Right? So I'm giving you the function y equals to cos theta, and it says at theta equals to pi by 4 and theta equals to pi by 2. So it says find the y coordinates, and the gradient of the tangent to the point, and the gradient to the tangent, which is basically he's asking you to find the derivative, right? For the following curves, so if you open up Cambridge book, it is 9i, question number I mean, don't open it because it's a sole example. So I need to find the y coordinate and the gradient of the tangent at the points on the following at this particular curve for these values of theta. Again, to at very simplistic language, find me the y value at this point, once you found the gradient of the curve. It's as simple as that. What is the gradient to the tangent for this function? Y equals to cos theta is what?
Negative sine theta.
Negative sine theta? Good. So you found y dash or f dash x or dy by dx. Then what is the next step?
The coordinates.
Sorry?
You find the values of.
So then what you will do is you plug in theta equals to pi by 4 in the original function. Find y. That's the first ask. Find y. Let's forget about everything. At pi by 4, what is y? I say, okay, my y equals to cos pi by 4. Right or wrong? Right? What is that value?
1 over root 2.
1 over root 2 or 2 over, whatever, root 2 over 2. Right? So the first part of the question is done for this particular value. It also says the gradient to the tangent. What was the gradient? Negative sine theta. So now what's the value of the gradient at this point?
Negative 1 over 2.
Whatever that is. That's as simple as that. Then you define. And then you do the same thing for pi by 2 as well. That's it. So if you visualize that in a graph, that's the cos graph, right? 0 to 2 pi. This is pi by 4. This is pi by 2. And this is what? Pi by 4, right? Yes or no?
I think it's pi in the middle.
Oh, sorry. My bad. Pi. And then this is pi by 2. This is pi by 4. Right?
Yeah.
So I need to find this value here, which is 1 over root 2. And I now also need to find, if I draw a tangent here, I need to find the gradient of the tangent at this point. And what is that? The derivative. So I find the derivative of pi by 4, find the derivative of cos x, and then just plug in pi by 4 and get my answer. That's the value of the gradient here. Does it make sense? Very simple question. Very simple question. All good? Make sense? Shall we stop here?
Yeah.
All right, I'll see you.